So when a perceptron iterates over a training set, it updates the weight vector every time a sample is misclassified. So let's take an example where we have an xi, which is a positive sample misclassified as negative sample, right? So the perceptron has misclassified it, so we need to update our weight vector. What this is written on slide 10, it is given as xi is a misclassified positive sample, right? So what this line means is it's a positive sample, but it is misclassified as a negative sample. So if you draw the graph, right, and you have positives this side, right, and let's say negatives here. So what currently happening is the decision boundary that we have built, it's misclassifying this positive sample as negative, right? So what we need to do is we need to push this decision boundary down or towards this positive sample in order to get it hopefully past our misclassified sample, right? So currently we have Wxi less than t because our yi, that is initially it's a positive sample, right, and it is misclassified as a negative sample, right? So we need a w dash such that w dash dot xi is greater than w dot xi, right? So this can be achieved by calculating a new weight vector w dash such that w dash is equals to w plus eta xi, where this is learning rate, right? Replacing this over here, what we get? We get wxi plus eta xi dot xi, right? As we know, xi dot xi is a positive sample, and we are adding a positive value to an existing value to get a bigger value, right? So therefore, we get a w dash which is greater than w, hence pushing the boundary towards our misclassified point or hopefully past it, right? Similarly is the case when let's say xi is a misclassified negative sample, right? Xi is misclassified negative sample. So that would mean that xi initially was negative in the data set but has been misclassified as positive, right? So again, if you try to visualize this, we will have positive here, negatives here, right? So we built a decision boundary such that this particular sample has been misclassified, right? So what we currently have is, as this is xi, wxi is greater than threshold, right, or t, because this line xi lies above the line, right? We need a w dash xi which should be less than w dot xi, right? We need a new decision boundary somewhat of this sort so that this negative sample gets classified as a in negative class, right? So in order to do that, we take w dash as w minus eta xi, right? Replacing this back here, we get wxi minus eta xi into xi, right? Which would obviously be less than wxi, right? Because this is a positive value and we are subtracting a positive value. So hence, as it is lesser than w dot xi, we are moving the decision boundary either towards or hopefully past the data sample, right? So that is why we update the weight, so as we change the decision boundary every time there's a misclassification, so as to get every sample get aligned in the right class.